Hey everybody, this is Mr. P coming to you with another Algebra 1 e-learning lesson. Today's lesson is for Thursday, May 5th, and this is looking at a portion of section 11.5, which involves solving rational proportions. Okay, so our strategy to solve these proportions is going to be the same as solving any other proportion, except we're going to have some other steps along the way. So remember, when we have proportions, which are basically two fractions that are set equal, where we have to solve for a variable, we cross multiply, like I would do 4 times 3x, which is 12x, 2 times 6, which is 12, divide, and solve, and I get x equals 1. So our problems today are going to have a few more steps involved. Okay, so first we're going to cross multiply first. Okay, then we're going to go ahead and some of them are going to involve factoring and solving. And the main thing, once we get our answers, we're going to want to make sure we plug back in and check. Remember, we discussed extraneous solutions earlier on. So any answers that don't work in the original equation, you do not include those as part of your final answer. All right, so let's just get right down to it. So we got 5 over x plus 1 equals x plus 2 over x plus 1. All right, so cross multiply. So I'm going to have x plus 1 times x plus 2 equals 5 times x plus 1. The right side, just distribute the 5, so 5x plus 5. Over here we FOIL, right? So x squared plus 2x plus 1x plus 2, right? First outside, inside last. Then I simplify, so 2x plus 1x, so I get x squared plus 3x plus 2 equals 5x plus 5. So since I got an x squared, that's a quadratic equation. Remember, to solve that, I have to have one side equal to 0. Okay, so we're going to go ahead and subtract the 5x and subtract the 5 from both sides. So what I'm going to have on the right side is 0. The left side, I'm going to have x squared minus 2x minus 3. And we want to see if we can factor that. So factors that are multiplying to -3 that add up to -2. Okay, so that's going to be x minus 3 and x plus 1. Right, those add up to -2, multiply to -3. So then I'm going to solve. So remember, x minus 3 equals 0, x plus 1 equals 0. And then I'm going to add 3 and add 3. So I'm going to get x equals 3. So I add 3 to both sides here. Subtract 1, x equals -1. Okay, those are my possible solutions. Now I have to check them by plugging them into the original equation. If they work, they're a valid solution. If not, they're extraneous, and we don't put that as part of our final answer. Okay, unless, of course, you're asked for extraneous solution. So x equals 3, let's check. So check. X equals 3. So I'm going to say 5 over 3 plus 1. Is that equal to 3 plus 2 over 3 plus 1? Okay, so are those two sides equal? What's 3 plus 1? 4. Right, so 5 over 4 equals 3 plus 2 is 5, 3 plus 1 is 4. Boom. So x equals 3 works in the original equation. Now we're going to check -1. Check -1. So I'm going to have 5 over -1 plus 1. Then I'm going to have -1 plus 2 over -1 plus 1. So what we should be able to see here, on this side, what's the denominator going to be? -1 plus 1. Uh-oh, that's 0. Same thing here. Okay, the top's going to be 1, but on the bottom, I'm going to have 0, which, remember, we can never divide by 0. Those are undefined. So we would say -1 is extraneous. Okay, negative 1 is extraneous. So 3 would be the only actual valid answer that works in the original problem. Okay, so let's go through our steps again. Cross multiply, FOIL, or distribute what we need to do, distribute. Then we go ahead and we get one side equal to 0. Factor, solve, check our answers. You gotta check both of them. Okay, so these, it's like when we did problems with extraneous solutions before. Sometimes we had 2 solutions, sometimes we had 1 solution, sometimes we have no solution. Okay, so that's the same with these types of problems. Let's do another one. All right, next one. Let's say I have 4 over x plus 4 equals x over x plus 25. Again, first step. That's always going to be a cross multiply with the proportion. So I'm going to have x times x plus 4. Then I'm going to have 4 times x plus 25. So I need to distribute the x on the left side, distribute the 4 on the right side. So x times x, that's x to the second, x squared. X times 4 is 4x over here. Okay, I got 4x plus 4 times 25 is 100. Remember, it's x squared, that's a quadratic equation, so in order to solve the quadratic equation, I need to get one side equal to 0. So I'm going to go ahead and subtract 4x and 100 from both sides. So what I got here is now 0, right? 4x minus 4x, 100 minus 100. So I get 0 on the right side. On the left side, I have x squared. What happens to those 4x's? 4x and negative 4x, they go away. And I'm left with minus 100. Okay, now we need to solve for x. So we should recognize that this is a difference of squares. Okay, where since 100 is a perfect square, okay, with x squared minus a perfect square, that's a difference of squares. So we think, what's the square root of 100? Okay, and that's 10. Remember, when we factor a difference of squares, it's always x plus the square root of this number. So x plus 10, x minus 10 equals 0. X plus 10 would give me a possible solution of, when I set it equal to 0, it gives me a possible solution of negative 10. When I set x minus 10 equal to 0, remember, set each factor equal to 0, that gives me a possible solution of 10. All right, remember, I need to check these now. So I'm going to check x equals negative 10 first. So where I see an x, I'm going to plug in negative 10. So 4 over negative 10 plus 4, okay, then negative 10 over negative 10 plus 25. So I replaced all my x's with negative 10. What I get here, I get 4 over negative 6, which simplifies to negative 2/3. So over here, on the right side, I get negative 10 over 15, which also simplifies to negative 2/3. Okay, so both sides of the equation are equal. Good. So negative 10 works. Now we have to check 10. So we have to check both solutions. So I'm going to check x equals 10. Again, I'm going to replace the x's with the 10. So 4 over 10 plus 4, is that equal to 10 over 10 plus 25. What's 10 plus 4? 14. So 4 over 14, this side, 10 over, it's going to be 35. On this side, okay, we have to reduce it. 2 goes into 4 twice, and this 14 7 times, so 2 over 7. This side, okay, 5 goes into both. 5 goes into 10 twice, 5 goes into 35 7 times. So both sides are equal. Okay, and what's that mean? That means 10 is also a solution. So I have I have two solutions to that equation, two valid solutions. Both work. Alright, so negative 10 and 10. Alright, we're going to try one more. Okay, so the last one, I got x plus 2 over x plus 4 equals x minus 2 over x minus 1. Okay, so just like we've been doing, start off by cross multiplying. Alright, so x plus 2 times x minus 1 equals x plus 4 times x minus 2. So I need to FOIL both sides, right? I have two binomials, I have to FOIL them together. So over here, I get x times x is x squared. Outside terms, minus 1x. Inside terms, plus 2x. Last terms, 2 times negative 1 is negative 2. FOIL the other side. X times x, x squared. Okay. Outside terms, minus 2x. Inside terms, plus 4x. Last terms, minus 8. Now we got to simplify it a little bit. So, x squared minus x plus 2x, so that's going to be plus 1x. Okay, so that's going to be plus 1x minus 2 on that side. And then on the other side, negative 2x plus 4x, that's going to be plus 2x. So x squared plus 2x minus 8. And remember, since it's a quadratic, we'll just start by, trying to get one side equal to 0. But here's what's going to happen. Notice I have x squared on both sides. What happens when I subtract x squared from both sides? It goes away. Alright? So then what I'm left with is x minus 2 on the left side and 2x minus 8 on the right side. And we're left with just an equation, linear equation that has a variable on both sides. So we're going to go ahead and get the x by itself. So I'm going to choose to subtract x from both sides first. So I have negative 2, and on this side I have, 2x minus x, that is x. So what I have is negative 8 here, x minus 8. And how do I get rid of a negative 8? I add 8. So I'm left with x equals 8 and negative 2, that's positive 6. Okay?